So,
Lathe.
so we have geometry, right? So we did the geometry, and the geometry for the mill, which quadrant we use?
The positive one?
Right, so for
One.
quadrant number one. So I don't know if you remember, like, what, 5 weeks ago? So for the lathe, which quadrant we're gonna use?
Two.
Number two. So we're gonna be using this quadrant right here, okay? Another basic foundation. So let's say we're gonna be working with this one. So it's gonna be a 3-inch diameter. It's gonna be a 3-inch diameter, and it's gonna be 5 inches long. 5.0, 3.0. Okay? Now, remember, this is radial. What does that mean, radial? So whenever, do you guys remember whenever I give you the analogy, if I'm making this window, do I have to make the whole window or just half of it? Half. And if I have to make all of those, I just copy them, right? So, in other words, whenever you have a lathe part, you only concentrate half of it. So what does that mean? So if I'm gonna draw this, I'm gonna come over here, I'm gonna put 5 over here, 5 over here, and from here to here, it's gonna be what? 1.5. That's it. Why? Because this 1.5 is gonna copy right here. I'm gonna show you how to do that radial. But the idea right now is you only concentrate. So if you see this, you only concentrate that is 1.5 I 5. Okay, because it's radial. 1.5 times 2, that's 3. All right. Same thing. We're gonna face. So our job right now, the first job that we're gonna do, we're gonna face 100,000. Okay? Just like the mill. So we're gonna face 100,000. All right. So let me go about another good foundation so we can understand this. All right. So let me see if I can draw this. Okay, so so it's gonna be this one right here. Then this one right here. Then this one right here. Okay, so let's see if this makes sense. Okay, so after we make our geometry, so 5 by 3, and we're gonna face about 100,000. Remember, in the mill, after you did the geometry, you have to do what? The stock, correct? All right, so this is your stock. So let's see. So this is, so let's put it, okay. 5.0. Is that correct? This is 5, this is 5. This is 100,000 that you're gonna face off. 0.100. This is the clearance, so you don't hit the chuck. So this is the chuck. Okay? So this is the clearance. And this is how much you're gonna be holding on the stock. So this is, you can call it clamping. Okay? So if so this is gonna be a standard 1 inch and 1 inch. So if I add all these together, what is that?
7.1.
7.1. okay? So the math is not hard. So it's 5 from a stop. Don't forget your 100,000 from facing, okay? Clearance is standard, 1 inch. And the holding, that we're gonna be holding the part is gonna be 1 inch. So it's gonna be 5, 6, 7, 7.1. Good? Make sense?
Mm-hmm.
A little bit? Okay. Because remember, if you don't have clearance and you're machining over here, you're gonna go all the way back and you're
Tool holder.
gonna hit the chuck. And that is very, I mean,
Crash.
it's a crash, and that's considered, any company considers that negligence, and they will think to fire you, definitely, on the spot. Okay, so you're always looking for clearance. This is a main clearance, and then you have other clearance whenever we're gonna do a inside diameter work. That's gonna be tomorrow. Good questions? Is it clear? That's a good foundation. So we're gonna be working in quadrant number 2. We're gonna be facing 100,000. Everything that you see diameter is gonna be half of it. Radial, think about radial now. And then whenever we go and make the stock, remember that you're gonna have whatever they tell you on the print, 5 plus 100,000, and then you're gonna have 1 inch for the clearance and 1 inch to chuck that part, because you gotta have something that you can clamp on. Good? All right, let's do it. Pena, ¿me ayudas con la luz, por favor? All right, guys, so let's go. All right, so watch me first, and then I erase everything, and then we come back and we go very slow, and we take some very good notes, okay? So I'm gonna go on bonded geometry. You guys already know how to do this, my geometry. So from here, it's gonna be 5.0, enter. There to the front. And over here is gonna be what? 1.5.
Half of your 3.
Correct, and then down. And then I'm gonna clean it. Keep this one, that one, and down.
So we're basically kind of using that x-axis line as the center point of total
Yes.
stock. Okay.
If that's how you see it. All right, good. So I have my geometry. That's all to do my geometry. Done deal. Okay. So now, how do I make my stock? So this is how you make your stock. Remember that before you used to select mill. So now we're gonna go ahead and switch to solid turn. Turning is lathe. So we switch into the lathe, and see, it gives you this crazy representation. The yellow portion represents your stock. This over here represents your chuck. And of course, the black portion represents your geometry. Obviously, this, if I'm machining this black geometry, I will crash. So that is incorrect. All right, so how do I make my stock? I need to make my stock. So this is a little bit different. So now you're gonna go to machining, common machining, and then machine setup. Remember, I'm gonna come back and then we're gonna make some notes. So after we go to machine setup, so over here, remember, I'm just a messenger. eSprit sometimes does a very good job asking you questions, and then sometimes like, why do they ask it like that? So start position for C. What does that mean? How much you facing off? How much do we have to face off?
100,000.
So we put it in there, 100,000. But see, they don't say a start position for C, it doesn't click. So in other words, translate, so that means how much you have to face off. If you have to face off 500,000, you put it in there. So then over here you have bar in2. So this is gonna be a solid bar. So bar diameter. So what is the bar diameter? We
3.
know it's 3 inches, but you know, thinking about the future, we have to machine the OD. So we have to make it bigger. So it's gonna be what?
Oh, bigger than 3, so
3.1.
3.1.
3.1, there you go. So you know I'm a very square guy, so 100,000 all the way around. Maximum diameter, same thing, 3.1. All right, here we go. Total bar length,
7.1.
7.1. Don't forget the 100,000, 7.1.
We have the clearance, the clamping, plus the face.
Right, 7.1. Part stock length, same thing, 7.1. Then over here you got different tabs, so we're gonna go to the next tab, assembly, and then you're gonna go to index turret, and this home position for X, Y, and Z. Of course, right now we're only working with 2 axes, so this is what it's asking you. Whenever, you guys already know what is a G28. So whenever the machine, the computer reads G28, it's called home position. So on the eSprit, they give you the option and it's telling you, hey, what is the home position that you want me to go? Because if you have a very short part and you have a very long travel, you don't want to go 30 inches back. In production, that is cost, is affecting you cost efficiency. So over here, so for right now, that machine in the back is, let's put it back 15 inches, 1.5. So we're gonna go 1.5, and then over here, 1.5. 15 inches for both, X and C. So it's gonna go back on X and back on C to 15 inches equal. And then you have something that is called main spindle. Main spindle, let me see where I can move this one.
You
Right
can,
here. Main spindle, the main spindle is asking you, what is the distance from my origin back? So, in other words, just take out whatever we're facing. How much are we facing?
100,000.
100. So it was 7.1 minus 100. But remember, it's a negative number because you're going this way, right? So you're gonna go
-7.
home position for X, Y, and Z. And they've been giving you kind of like a negative number. So it's gonna be -6. No, that's incorrect. -7. Okay? Whenever we click OK, look at this. So now you can see over here is 1 inch to hold apart. From here to here is 1 inch for clearance, so you don't crash. This right here is 100,000 for facing. And then this right here, what is this? Is 100 or is a 50?
That's a 50, because you have
That
50
is
on the
correct.
bottom
And
for
if
it
you
to
can
hold.
see, is half of this. Why? Because you got 50 on the top and 50 at the bottom, so it's radial. Good? All right, let's do it together. You go slow and take notes. So I'm gonna go, and new, save changes, no. All right, so let's make it together. So I'm gonna go to line 1. From the vertical line to the left, 5.0, enter. To the right, 5.0, enter. From here, it's gonna be 3-inch diameter, so it's gonna be 1.5, enter. And then at the bottom, Same thing. And then we just gonna clean it. We good? Everybody got the geometry? Okay. All right. Guess we'll wait for Nancy to come back. Let's see how much memory we have here. So after this, so we're gonna go switch to solid term. And just by looking at it, that will tell you, you know, like, hey man, this is wrong, I will crash in this thing. So you have to accommodate that stuff. So where do you go? This is a little bit different from
Machining,
So you're gonna go to machining.
common.
But the good thing about this, whenever you go to the next the advanced class, everything that you're gonna be making is gonna be from machining. So it's a good practice. So machining, then you're gonna go to common machine, machine setup. And then we're gonna answer some questions. So a start position for C. So we're gonna face 100,000, so we're gonna go 0.1. We're gonna select bar or tube. This is bar. Bar diameter 3.1. We're gonna make it 100,000 bigger. Maximum diameter. What is the maximum diameter? We're gonna count everything. Is 5 plus 1, that's 7, plus the 100,000 that we're facing, 7.1.
Diameter.
Oh, I'm sorry.
That's
3.1.
3.1.
And then over here is 7.1. Thank you. So then the same over here, 7.1. So we're done with this one. If you like, it'd be great if you take a picture, you know, so you can have it. Because just the same, if we don't know how to make the stock, if you make the stock wrong, man, everything is gonna be wrong. So for your exam next week, so it might hurt you. So assembly, so then we're gonna go to index storage 1. And remember, just remember, G28, home position. So home position, you're only dealing with two axes, X and C, so you don't touch Y. That's gonna be for next class. So it's gonna be 15 inches back, 1.5. And that's all you change in this page. Then we're gonna go to the next tab, main spindle, and home position for Zulu. And it's giving you, it's putting in there a negative sign. All right, so that kind of tells you, all right, so from 0 back, so it's gonna be my stock, my clearance, and my holding. So that's gonna be 7. 7, click OK. And now it has to make sense, whatever you see. 1 inch over here, 1 inch over here, 50, and there. Yes, sir.
Would you press right there for that?
Okay,
Where's that at? Negative 6 is where?
Zulu, look for X, Y, and Z.
Home position?
Home position.
Oh, okay,
Click OK.
Come on, Nacho.
Right, and right now you have to make sure that you have 1 inch, 1 inch, the stuff for facing and the stuff for the outside diameter. Yes.
So on this part, we clicked machining up there, then common, then tool setup,
spindle.
right here under assembly,
Negative.
main
sign.
spindle, we're going your home position X, Y, Z, you're going negative 0.7 point.
So if you see, tenías un 7, ¿no?
Sí.
Por eso tu chop Lo viste que estaba acá.
Sí, está acá.
Paul? Got it?
Good job, Paul.
All right, so let's practice a bit.
Whoa, 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 whoa. We're going from. That's a break.
All right, so make sure that you got good notes and you took the pictures that you need. Probably save that one as a template with that drawing so you can have it, and then let's practice. All right, so let's make something different. All right, so let's see, outside diameter, let's make it, is oversized. My outside diameter is oversized by 200,000. Let's see if you can make this one. Look.
The same one, but one size 200,000.
Right, let's change it a little bit for you. So, let's go up. Let's go 3.0. Let's go, that's, let's go 2.0. All right, so let's see if we can make that one. All right, so 3 inches, still you gotta face 200,000, and on the turning OD is 200,000 oversized. So what does that mean? So you gotta make 2.2.
So if you want the OD?
OD 200,000, not 100,000.
Well, spacing wise, just 100.
Right, facing 100,000, and then the outside diameter is oversized by 200,000. So your math is gonna be 2.2, and then over here you're gonna add 100,000. Whenever you finish it, call me so I can check it.